Greetings and salutations, everybody in YouTube land. This is Bob Martin, the RCSubGuy with the Nautilus Dry Docks. And if you're tuning in, you're looking for RC submarine goodness. Fortunately, we got a little bit for you. We got a 38-inch Red October Typhoon to finish up, and a giant shark. This is going to be a truncated week because I've got some business travel going up to Canada. We better get our stuff started. Let's build a control box. So this is what's called a project box. You can get them on Amazon. They're super cheap. You get packs of 2, and they're IP65 rated. We're not going to be diving shark deep. You know, you're not going to be going down 10, 15 feet. You got to keep your eyes on this thing. When you get it, the seal is out. So the first thing that I'm going to want to do is apply the seal to the lid. And when you do this, you want to start on the long face, because it's going to make sealing the seal a lot easier when you get back there. So I'm going to go ahead and around the outside, and we'll come back in a second. When you get back to this point, you can see we're going to need to trim the seal. Now, you do not want to stretch it and then cut it, because then it'll pull itself back. You don't want to do that. So what I'm actually going to do is cut it a little, like a 32nd of an inch longer. And then that way, when I put it in and force it down, it's going to want to push itself together. Now, another thing that you can do that's a really good idea, just put a little dribble, little tiny smear of RTV on that joint. And then that way, when it joins together, it'll actually like fuse and make sure that it's 100% waterproof. What I've gone ahead and done is screwed the top of the lid back on so that the silicone conforms to the inner lip that creates the other interface for the seal. I'm just going to let that kick off for a little bit. We're going to talk about wire connectors. Now, I like these ones. I got these off of Amazon. These are 6-pin connectors, which is opportune because we need to connect 6 wires. 3 for each of the electronic speed controllers that pass through to the 3 wires on each of the thrusters. I like putting the female receptacle into the waterproof box, but you can see there's like a little lip on this side, a little flangey thing. I'm going to cut, grind, and otherwise remove that so that it creates a perfectly square interface on the inside, so that when we cut our hole, it's a little easier than trying to notch and all of that stuff. So the connector has been trimified and measured it with the old calipers, 18 by 18 millimeters, and they have radiused corners, 6 mil in diameter. So what I got ahead and did, drilled 6 mil holes at each corner, and now I'm going to bust out a specialty tool. If you follow my channel, you'll know what we're talking about. This is the ultrasonic cutting knife. Extremely expensive, but absolutely worth it if you're a hobbyer. Basically, this blade vibrates at something insane, like 40,000 cycles per second or something like that, and just slices through plastics and other stuff like butter. If you don't have that, you're going to have to break out your rotary tool and grind it all out. I'm going to use my knife. So this is what we got going on here. I have a nice precision fit. It's actually friction fit. It's hard to get it in and out, which is what we want. And I'm using a little bit of acrylic cement. This fuses all kinds of different plastics together, and it actually melts it together as opposed to just binding it. So I'm going to press this down, have a nice bead around it, and that'll be permanently adhered in there. Well, we're not off to a good start. My glasses broke. Literally while I was filming the intro. It just fell right apart. Now I gotta glue them back together again for the height of fashion. And I can't see in order to do it. Getting old sucks, people. Alright. Let's regroup on where we're at right now. Box. When we left off last week, we put our connector in there with some acrylic cement. This is not working. Dang it. There we go. Now I can see. These are my old glasses. Had these for a while. Okay. Waterproof box. Where we left off last week. Installed the connector. Now what we need to do is install 2 electronic speed controllers, coupler, and a receiver. But before we do that, I got to figure out this whole radio situation. So this is what I picked up. This is like what the drone guys use, apparently. But it's got an XR1 and an SPP, and then there's a bunch of programming. And I'm fighting having the time to plow through this. In the meantime, what I may do is just throw a FreeSky radio in there. FreeSky radio is about $280, which I would rather not have to do, but it would at least get this build going. And we'd have these other radios for later. So these electronic speed controllers, I really like these. These are Diamond Hobby Pythons. And in theory, when you buy them, they're waterproof. In practical application, they're not waterproof. Which doesn't matter in this case because we're putting them inside a waterproof box. They got these little water cooling nibber nubbers on there, but I want to mount them on the wall of this case, and the nibber nubbers stick out too much. So I cut off the nibber nubbers, and now I can put them right in here on the side. And they'll be completely out of the way, leaving the entire center section for the receiver. So here's the box thus far. We got our electronic speed controllers mounted, wires run, and I got my little power distribution block in here. Now you could just solder these together, but this kind of makes it easier to kind of put together and take apart. I still got room underneath for the receiver, so I'm not worried about room, and this lid has a lot of real estate up in the top there. The other thing I did, I drilled 5/32 hole, 5/32 brass tube, and secured it with thin cyanoacrylate. So now we've got 2 inputs in here because we need power. We got motor outputs, but we need power. So if you're unlike me and you're going to be shopping for new connectors, I just had this connector, so I was going to use it. You would get an 8-pin connector instead of a 6-pin. And then that way you would have positive and negative in, and then the 6 control wires for your speed controllers, and then you wouldn't have to go through this whole wire situation to get power in there. So the way that this is going to work, we're going to take our wires, we're going to put some silicone tubing over the wire, and a little bit of silicone oil. A little spray will make this go on easier. And then you feed this through. And then once you do, you have a waterproof connection, and you do a little zip tie, and you've got power in there with no possibility for the water to get in there. Here is the completed electronic box. I got my receiver underneath there and my power distribution block. And like I said, lots of room, no problem. So this is, in theory, all done with the exception of putting our little silicone sleeves on, but I wanted to wait to do that until after I'd put all my guts in so I could pull it to the correct tension so we didn't have extra wire in there. Just make sure when you close this up now that there's no debris in this or the lid, and that you're not pinching any wires. And then once that's done, we can close it up. Done, ready for testing. All right, a couple of things to note. Now would be a great time to do some testing before you button everything up. So you can see in this particular case, I've got some jumpers going to the left motor. I've got my radio programmed, and sure enough, we've got motorage. Now, another thing, we got 2 electronic speed controllers in there. Each one of these particular ones have a built-in battery eliminator circuit, which is what feeds the receiver. You can't have 2, you only need 1. The receiver only needs 1 source of power, be it a built-in BEC or a standalone BEC. Don't double or triple feed your receiver. So what I mean by that is you've got these leads from the speed controllers. The red wire is what's going to be supplying 5-volt power to the receiver. So just snip one, leave the other one intact. Now my receiver's got power and we're in good shape. So I've tested my left motor. I'm going to go ahead and test my right motor. And if everything goes well, we'll button this up and get to some programming. Let's talk about steering in this crazy thing. So there's a couple of different ways that you're going to do this. If you're of the old school family and you're going to throw some old like 1990s low frequency radio in there, hey, good on you. What we need to do though is mix some steering or put them on 2 separate channels. So in order to move forward the way I have these wired, the left motor would need to spin counterclockwise and the right one would need to spin clockwise. Now, there's a few different ways of doing this. Number one, you could put each one on a separate channel and control it like a tank. So you would use, say, 2 sticks, left and right to control the steering. Or you could get a throttle jockey module. And the throttle jockey is basically like a postage stamp size little module that mixes the channels together. So that's available from my online store, and you just go ahead and program that. And then you would be able to control it from a single stick like this. And so forward, backward, left and right. Simple, simple. But with these modern radios, you can do all of that in the programming. So it saves yourself some money with the modules. It saves you some wiring. It saves a potential point of failure. And in this particular radio, you do it through the mixes. And so I set up a throttle mix that makes the model go forward and back. And then it mixes to go left and right. So differential steering. And here's some examples. So I'll go forward right now. They both go forward, reverse. Now if I go left, they should both spin in the same direction, which means one of the motors will be pushing and one will be pulling. Which it is. And it is. And I really can't say enough about these modern radios. You guys have heard me pound this in over and over again. It just gives you infinite amounts of flexibility. You can adjust the rates of mix and like neutral points and exponential curves and all sorts of cool things. For those of you who don't know what I'm talking about, maybe the old low frequency radio would be the way to go. You don't need to worry about it. But if you really want to play Tweakify and make this thing run perfectly, this is how it's going to work.
Hey there everyone, it's Logan, and I wanted to show you a bit of what I was getting up to today. So I am working on some parts for the big drill. Earlier I got the remainder of the painting done for these pieces. I've got all of the wiring that is going to lead into these little nodules, the smaller ones over here. But what I've now moved on to is the railings. I've already finished 2 sets, and I wanted to show everyone something pretty important when completing repeat projects. When you're just doing something once and it's a one-off, it's fine to freehand it. But in our case, we have, I believe, 2 sets of railings per large drill, which means we have a lot of drills to go. But making a jig like this makes it insanely simple and super nice to burn through. This was just made super quickly with 3D printer, but you can see the overlay matches exactly what I'm building. And with this, the process of making these railings goes from an hour-long per railing process down to 5-10 minutes, and each round is getting faster. If I had a spare rod here, I'd show you a bit better, but with the jig, it's just that simple. You just get your brass rod, load it where you want to go, and that's it. It's making a carbon copy of 2 parts insanely easy.
And just like that, it's Wednesday. And this is the last day of the shop because Logan and I fly out early tomorrow morning for Canada. We're going to be there until the 4th, which means we're going to have a long gap between our next video. So apologize, you're going to need to get your fix someplace else for a little while. But we're still going to get some work done today. My fancy clock gave out yesterday, and we had to get another one. Same day delivery from Amazon. Kind of like this one. It's got a night light in it. What we are going to move on to now is the installation of the tail for the shark. And this is set up in like a modular kind of fashion with a hinge system. Just goes like that. And it just so happens that a 3/16 pin is perfect for a hinge pin. So what we need to do, though, is to create a stop on the top of the pin. And I'm just going to use a little bit of brass tube that will slip over top of that so that when it drops in, it doesn't keep dropping all the way to the bottom. So to start out with, take your 3/16 pins, drop them in, mark them, cut them, and you've got your lengths. And then we're going to grab some tube and make our little stops. So these are the pins that I created. Like I said, just a little bit of tubing on the end to stop it from slipping through the holes. And I've got these two in here, one in here. And the cool thing about this is once this, tail assembly is put together, it's really easy to put on. The entire thing can easily be removed for transport or storage or whatever you want. You just grab this pin, pull it out, and then you've just got a body section. It's pretty cool. Now, one of the issues here is the first and second tail section, in my opinion, swivel just a little bit too far. You know, when they turn all the way, it kind of looks like poor shark's got a broken back or something like that. So what we need to do is just put a little flange on the inside here that'll bump up against this and stop it from over rotating. So I'm just going to use a little bit of flat plastic, or I mean, hey, you got a 3D printer. You could just 3D print one if you wanted to. I'm going to do that right now. I'll give you the measurements, and we'll correct the broken back syndrome. All right, these are the two sets of spacers that I installed. First one's super easy, 38 millimeters wide. So just a rectangular piece of plastic, just glued. Let's see here if I can get this out. 38 millimeters wide, and you can make this long. Now the impact point is kind of up here, so you don't need to necessarily make it this big, but makes it nice and big. You don't need to worry about support flanges because all the force is inward, compressive on this plastic, so it's pretty rigid. And then the impact point for the piece back here, which is about 1/2 inch from the leading edge, is 21 millimeters. So you can make a 21 millimeter rectangle and glue that in right there. And when you do that, you end up changing the impact points for the tail section. Let's see if I can get this back on. So now it doesn't look like he's got a broken back anymore. So with everything that was going on with the loss of the USS Texas, there's a lot of talk about failsafe devices, and there's a gajillion armchair experts on YouTube all chiming in about all these complicated magnetic release buoys and tethers and electronic doodads and all of that stuff. All doable, and they could all work. But one thing that did come up was the old gas ballast systems. And if your boat ended up on the bottom, you could burp the ballast and look for bubbles. Now, if you don't have a gas ballast system, you can't do that. And you're reliant on the cylinder actually being functional and you having control of it. So, somebody had this idea about these things called buzzer rocks. And they're for aquariums, and they release oxygen. So they look like this. I ordered some. It took a while. They're apparently very in demand right now. Anyhow, the package looks like this, or at least this particular brand, Buzzer Rocks. I've never used them, and I don't know what they're going to do. But in theory, you drop this in like an Alka-Seltzer tablet, and it creates bubbles. And my thought was maybe we could make a little cage inside the hull with an 1/8 inch hole or more holes, or lots of holes. And as the boat is traveling, it would be leaving a string of bubbles behind, which could look cool all on its own. But if it settles on the bottom, you could take a kayak, a boat, or even swim and look for these bubbles, coming to the surface. I don't know how effervescent this is going to be. Let's find out together. So I stole this from Logan's side of the table. This is just a little glass of water that he was doing the water slide decals for the drills for. So let's take this. Let's do it together. Are you ready? 1, 2, 3. Well, that's underwhelming. Oh man, I was really hoping that was going to be a little more energetic. Well, it's all about surface area. You know what? Let's pop it out, crush it up, and see what happens. So here's my crushed up tablet. Let's grab all of this stuff here and drop it in. Man, I don't even see any bubbles in here. What is up with this? Well, that sucks. $8 for nothing. Right. Okay, well, that's why I'm here. I spend all my money so you guys don't have to. So that was disappointing. I was really kind of hoping for a nice bubbly mess that you'd be able to track it with. We need to find something else that'll emit bubbles. That you don't have to that you don't have to recharge. You don't have to control by electronics or rely on the radio or anything. Something simple. A KISS system. Keep it simple. Super stupid. Yeah, let me know. Drop your comments down below. There's got to be something out there. You guys are smart, right? But on the topic of failsafes, I did just throw up a bunch of those piezos that I got. 95 decibels. They work from like 3 to 20 volts. You can hook them up to a 9-volt battery. You could either just make them a standalone system in their own little module that you tuck in the boat, so it just kind of screams all the time, which you wouldn't hear, if you're not in the water, because the water would dampen it. Or you could trigger it with a loss of signal event or whatever you want to do, and it would just scream and allow you to in theory, find your boat. Our results when we were testing piezo were inconclusive. I just had it sitting free in a watertight container, which wasn't transferring that sound as good as it should. If I would have mounted it right to the exterior of that watertight box, it would have resonated through the water a lot better. And in theory, these are actually waterproof. You could put them in the water and they would be even better. So yeah, they're up on my site. I think they're like $5 a piece. I got 9 of them left. Jump over, grab them. It'd be worth it. Now, before we can install the waterproof box, we need to install flotation foam. And before we install the flotation foam, we need to drill a vent hole. So if we take a look at Mr. Shark here, when he's kind of level, the air is all going to go up, and the highest point is right here. So what we need to do is exceptionally carefully drill a hole up in the very tippy top of his pectoral fin going down to allow all that air to vent out of the hull. Now, I drilled it from the inside with an extended drill bit. You may not have one of those kicking around your shop, in which case what you're going to want to do is notch that with your rotary tool, kind of flatten it out, and then set your pilot hole. And once you have a pilot hole with a very thin drill bit, say like 16th inch drill bit, take your 1/8 inch and drill backwards. Push it in until it goes through. If you don't go backwards, this will shatter, break the whole tip off. You'll be angry. You'll blame me for a crappy product. That's just the way it goes. Do it properly and it won't be a problem. Now the next part is going to require a little bit of artistry on your part. You need to do some carving and cutting and whittling. We're talking about flotation foam. So this is the way you get it. I got this off of Amazon. You get 2 chunks for like $10, which is expensive because you can get this at the hardware store in like a 4x8 sheet for probably not much more than that. But this is convenient and it gets delivered right to your door. This is 2 inches thick. You can also get it in 1 inch thicknesses. I just ordered a bunch because I go through a lot of this. From that, I carved these. These are the flotation inserts that will live in the top of the shark. And in theory, this is going to be roughly the correct amount of flotation that we're going to be looking for. The reason it's split in half is for ease of installation. If we take a look inside, a couple of things to note. You've got that big support bar in the back, which is where you got this notch in the front for. And then you need to avoid the intake shrouds on the inside there, the pressure boxes. And that's what those little notches are for. And then you'll notice we've got rounded, contoured bodies because, oh, the top of the shark is rounded and contoured. So this is going to be a lot of trial and error on your part. Just cut, carve, cut, carve, cut, carve. This may take you an hour to get it looking nice. Just don't go shoving rectangular blocks and gluing it in with hot glue and doing all sorts of nastiness. We want a nice flat surface because we need to mount our control box to it. So let me show you what these look like sitting in the hull. Isn't that pretty? Nice flat surface. This isn't glued yet. But you can see, you know, we're using most of the interior area there. We're not leaving massive voids that aren't going to do anything for us. So this is what you're aiming for here. Something like this. Maybe you can do a better job than me. But now all I'm going to do, I'm going to tack this in place with some RTV. All the force is going to be up against the hull. So really the RTV is just a placeholder. It's just holding it. That's all it's doing. And then we will be able to throw our box in there and start doing some wiring. While that silicone cures, don't touch it. Just leave it. Don't touch it. Let it cure all the way. We're going to work on installation of the belly hatch. So we take a look at our belly hatch here. We got a little hole in the back and we got a little pin. All built into the files. So cool. Just slips like that. Look at that seam. Pretty slick. Now I've gone ahead and marked out a hole in here because we need to have some way of securing this together. And all we're going to do for that, weapon of choice, stainless steel M6 flat head bolt. So I'm going to go ahead and pilot this out and then open it up to about 6 mils on the top. And we'll tap the bottom in the flange there, which is nice thick plastic for it to bite into. And then we'll be able to secure our hatch on to the shark. So here is my drilled and tapped hole for my bolt. And went ahead and drilled this out. Again, guys, drill backwards. Do not crack that. You're going to be upset with yourself. After I drilled it, I countersink it with a countersink bit. So now this fits nice and flush. Looks pretty darn slick. Let's test it on the boat. All right, slider door in place. Slide. Thread. Nice. There we go. I like it. I like it a lot. So we got our belly hatch on. Now we're going to be working on some pectoral fins. Now these are set up so that they offer some degree of positionability so that you can fine-tune the performance of your shark. So they slip on these pins here, and then I designed them with a little hole that you can tap out for a threaded bolt. Now, the actual position, you know, you're gonna need to dial in when you are playing with it. I can't remember. I think it was like this, roughly. Usually, I don't know. Start out with it being flush when you're trimming your boat. I'm gonna use some big stainless socket heads, and the reason is you can get your fingers on there. When you transport these sharks, you want to disassemble it as much as possible. Regardless of what you print it in, it's not going to be exceptionally strong just because you got lots of things sticking out, right? So removing the pectoral fins, removing the tail, probably a really good idea. The reason I'm using these, you can just use your fingers, take it off and pop it out, as opposed to having to carry a whole tool set with you to take it out. Yeah, you're going to see a little nubber sticking out under the belly, but the only way you're going to see that is if you crawl underneath a shark to take a look at it, which is not a big concern to me. Let's just pause here for 1 second, take a look at the inside guts, because I got the parts laying in there, and I'll show you what it's going to look like once it's all assembled. So you can see I've set my waterproof box on the inside there, and then I've got the battery sitting on top. So the battery is low, because this is upside down. The flotation is high, so we've got a lot of stability. Odds are good we're going to need to also add some additional weight, which we're going to attach to the belly later on, but you can see lots of room inside, easy to work on. Here's all our wire outputs right here. Those will be really easy to make up as well. This is a pretty slick little unit. You guys saw, I think, was it last week, I was talking about the Ohio hull, the new product from Randy Sanders, and this thing looks good. We just finished printing the prototype in ABS glass-filled plastic. I'm going to show it to you. So these are the parts. I'm reprinting this one. This one came up messed up, but all the other parts look really, really good. It's a sizable boat. You know, I think it's almost 6 feet long with a 5.5 inch beam, and you can see got a lot of really nice details in here. And when you print it out in this ABS, it is really, really rigid, really strong. And the way this is set up, you can either have a solid upper hull if you're not interested in the missile hatches, or you got all the missile hatches that you can put on there as well, which would be super cool. I would love to see this, you know, done up on RC, so all 20 of these missile hatches open and close at the same time. And with a boat of this size, you know, you can make it happen. Could totally be done. So if anybody's interested, these files are available on my site. You can print out your very own. I don't know what I'm going to do with this. I don't know. We're gonna put it all together and fiberglass it and make it super hard and get it all set to go. Maybe we'll offer it as a built hull ready for a cylinder, or you know, maybe I'll grab a 100 mil dual tank cylinder from Ron. That'd be the perfect cylinder for this boat. Yeah, maybe I'll do that. Well, unfortunately, we are out of time this week. Got to get to work, and then I got to end up packing, so have no more shop time today. That's the end of this video. Thanks for tuning in. The next video should drop the end of the week of August 4th, which is only going to be a couple of days of work, but we'll be back. We can let you know what was going on. I'm feeling good about things. We got good progress on the Shark. Typhoon is almost ready for trimming. We're in good shape, and I'm feeling good. One big note before we sign off here. Big thanks to Rob T for his donation for the Diving Deep donation imperative. Again, if you guys ever want to donate to the dry docks, you can do it right on there. Everything from $5 to whatever you want to give. It's all appreciated. With that, we are going to let you go. Drop your comments, do the favorites, subscribe, do all the stuff. We really appreciate it. It helps us out a lot. With that, we're going to let you go. You have a great rest of your day, and we will catch you next time.